Hello, Year 10. Today we are finishing off the topic by learning about regions on the Cartesian plane, but a couple of revision questions first. And this first one is from a few lessons back now. It says, find the equation of a parallel line to the line y equals 2x minus 5, passing through the point minus 3, 4. Now, if it's parallel, it means that it has the same gradient as the line that we're given there. And the gradient of that line is the 2. So we know that m is equal to 2. We also have been given this point here, which we're going to label x1, y1. Because to find the equation of the line, I can use y minus y1 equals m x minus x1, which is the point gradient formula. So subbing in, we get y minus 4 equals, gradient is 2, x minus minus 3 is a plus 3. Expanding, we get y minus 4 equals 2x plus 6, and then add 4 to the other side. And then we get y equals 2x plus 10. Done. Okay, and then more recently, we've been learning about simultaneous equations. So this one says to solve the following pair of simultaneous equations. It doesn't specify a method that I have to use, but looking at the second equation, we see we have y by itself. So this is set up very well to do a substitution. So I am going to sub equation 2 into equation 1. So that means the x minus 2 is going to go into that y. That will give 2x minus 3x minus 2 equals 8. Expanding, we get 2x minus 3x plus 6 equals 8. 2x minus 3x is negative x plus 6 equals 8. Subtract 6 and we get 2, and then dividing by negative 1, we find out that x is equal to negative 2. Finally, we need to sub back into one of the original equations. Let's go into equation 2. And we get y equals minus 2, which is negative 4. So this is two graphs that we're talking about here. So the point of intersection is minus 2, minus 4. Okay, so hopefully that is all fresh in your memory. Let's move on to regions in the Cartesian plane. So we know how to sketch straight lines, but sketching regions are actually sketching the inequalities. So to get us started, it says here, the graph of an inequality represents a region of the Cartesian plane. For example, to graph the region represented by y is greater than x plus 1, first of all, we just need to be able to sketch the line y equals x plus 1. There will be two different types of lines that we use. Sometimes you can see here we have a dotted line, and sometimes we will use a normal solid line. The solid lines are used, so solid lines are used if you have the less than or equal to or the greater than or equal to, the ones that have the equal to signs on them. Kind of like your open circle and your closed circle when you're doing it on a number line. However, if it is just a less than or greater than sign, then you'll be using a dashed line. So maybe as a little summary, a less than or equal to, greater than or equal to means that we're going to use a solid line. If they do not have the equal to signs on them, we're going to use a dashed line. Okay, so that dashed line is the line of y is equal to x plus 1 because it has an intercept here of 1 and the gradient is also 1. So rise 1, run 1, and we get the second point. So we can sketch that line. Okay, once you've sketched the line, then you have to decide which side of the line is going to represent the solution, which we will shade in. To do this, you must choose a point that is not on the line. And often the easiest point, if it doesn't go through it, is the origin. The origin is always a nice value to sub in. You're subbing in zeros. So that's what's done here. we're going to sub in the point 0, 0, which means x equals 0 and y equals 0, and we're putting that into this inequality. So we have 0 for the y is greater than 0, which is x plus 1, and 0 plus 1 is equal to 1. Now we look at that and we go, is 0 greater than 1? Is that true or is that false? Well, I think 0 is actually smaller than 1. So that means that this is actually a false statement, which means that the point that we tested, which was the origin, so this point over here, the origin, is the wrong side to shade. We shouldn't shade this side. That's the wrong side because it was false. So instead, you'll see down here on the next graph that the correct part to shade was the other side of that line. Okay, so that's how that should look. Now that was just done for one region. Often we can have 2 or even 3 regions all on the same graph. It is important that every time you do this, you obviously need to sketch the straight lines with the correct dotted or solid line. You need to make sure you show that you've tested a point every time and that you've shaded the correct region. Okay, let's have a play with some examples. Check each of the following using substitution to see if the inequalities are true or false. So this is just practicing the true or false part. We're going to sub 2, 3 into the equation 2y minus y is greater than 6. So the x is 2, the y is 3. We sub them in. We get 2 times 2 minus 3 is greater than 6. 2 times 2 is 4 minus 3, that's 1. Is 1 bigger than or greater than 6? No, I think 6 is actually bigger. So that would be a false inequality or a false statement. Let's do the next one. We want to sub in x is 1 and y is minus 4 into this new inequality. So that would be 5 times 1 plus minus 4 is less than 6. That's 5 minus 4 is 1 is less than 6. 1 is less than 6. That one is true. So if we were doing the graph part of this, the one that is true, we would shade that side where that point was on because it was true. Whereas the one that was false, we shade the opposite side of the line. Okay, question 2. We want to write down the inequality to describe the region shown. Okay, so first of all, I need to know the equation of this dotted line that we can see here. So I'm going to find the gradient by doing, I'm just going to do the good old-fashioned rise over run. So the rise of that triangle is 2, and the run is 5. It's going uphill, so it's positive, so that's done. Then the y-intercept, which we call c, is equal to negative 2. That's the value that it's going through. So the equation of the line would be y equals mx plus c, which is y, well, I'm going to put an equals for now, but I have to change that. Y equals 2/5 x minus 2. The trouble is, because it's got a shaded section, I need to work out what sign needs to go here to know which side I've shaded. Now, typically the best way to do this is to have a bit of a guess and check it by subbing something in. So anything that's above the line, you think it's bigger, it's above. So to me, that says that that should be a greater than sign. The shaded part is on the greater side of the line. It also should not have an equal sign on that because it's a dotted line. So I think it's going to be y is greater than 5 over 2x minus 2. And I'm going to just over here check it by subbing in the point 0, 0. I'm going to check the origin to see if that's correct. So x is 0 and y equals 0. So I have 0 is greater than 2 over 5 times 0 minus 2. 2 over 5 times 0 is 0, so that would just be equal to minus 2. 0 is greater than minus 2. So that is a true statement, which means that I have done that correctly. So this is my correct answer. Question 3. Shade the correct side of the line to make the inequality true. So the line has been drawn for us. We have our equation up here. So I just have to test which side to shade. So again, because the origin is not on the line, I'm going to use it. I'm going to sub in the point 0, 0. So that will be x is 0, y is 0, is greater than or equal to 1. 0 plus 0 is 0, is greater than or equal to 1. But 0 is not greater than or equal to 1. That is false. So the origin, which is here, that's the wrong side of the line to shade, which means we need to shade in the other side. That would be the correct part. You can always double check by subbing in another point on the other side if you want to. If you have time to do that on a test, that would be an extra way of checking. Okay, so those questions were all doing little bits, practicing little parts. This last question brings it all together where we want to shade the region which is shown by 2 inequality sections, equations there. So I am, down the bottom here, going to test the 2 different equations, but first of all, I need to draw them. Now, to draw them, just ignore the inequality for a minute, and you either need to use the point gradient formula or the x and y intercept formula. Either one is fine as long as you've shown the 2 points that you have used. So, if I think about this first one, y is greater than 3 minus x, the y-intercept of, actually let's start with the gradient. The gradient would be equal to -1 and the y-intercept would be equal to the 3 because they're written in a different order to usual. So on the graph, we start with the y-intercept, 1, 2, 3. So there's my y-intercept. And a gradient of -1 means I can either rise 1, run 1 to that way, or if you want to, because it's already pretty high, you could go down 1 and across 1 the other direction. I've shown 3 points there. You only have to show 2, but that is going to be my line. It's going to be I'll use a ruler. That is going to be a solid line because it was a greater than or equal to sign. So there's my line. Making it nice and long because it's going to need to intersect with the second one that I'm about to draw. I'm going to label the intercept on there. Okay, moving on to the second one. 2y is less than x minus 2. So let's down here go 2y is less than x minus 2 because I need to divide by 2. So dividing by 2, I'd get a half x and minus 1 so that I can read off that my gradient is a half and my y-intercept is -1. So putting that on here, we're going to have y-intercept of -1 is there. And then we are going to rise 1, run 2 to the positive side. This time, this one's going to be a dotted line because there was no equal to sign on that inequality. And we're going to go dot, 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 dot. And we can see that our 2 inequalities have intersected. So I've drawn the lines, I have the right dots and solid lines happening there. I do need a few more labels. So this is -1. This one's going through 2. That point there is the point 1, 2. Okay, now I need to do the testing to show where the correct shaded region is. So I'm going to write the first equation over here. Y is greater than or equal to 3 minus x. So that was the first one. This was the second one over here. Now you need to show the testing. So underneath here, I'm going to test point, and the origin is not a part of either of those lines, so let's test the origin for both of them. We test the point 0, 0. So that would be 0 is greater than or equal to 3 minus 0. 0 is greater than or equal to 3. Wait a second, that's not true because 0 is smaller. So that is a false statement. So looking at my first line, the solid one down here, the origin is the wrong side to shade. So that means the shade, I'm going to do it lightly because I have to test the other one yet. It's going to be on the higher side of that first line. Now we're going to test 0, 0, the origin, for the second equation. So putting that into, I'm going to put it into my, simplify the second line here. That would be 0 is less than half times 0 minus 1. Half of 0 is 0, so it's 0 is less than minus 1. That's wrong again, that's false, because minus 1 is smaller. So that means the origin is the wrong side to shade again, which means we want to go on the bottom side of the dotted one. And the section that's in common is this part out the side, where both of those shaded sections overlap. So that part there, coming out the side, that's the bit that would solve both of those region statements. What that means is if I pick a point anywhere in that section, so if I pick the point 5, 0 here, if I sub the point 5, 0 into both of those equations, then I would get a true statement out of that, which means it works for both of the equations. All right, well, congratulations. That's the end of our topic. You have one more exercise to finish, which is exercise 1L, and then we're on to revision activities.